Okay, welcome back everyone to Grockit's OG TV. This is the GMAT edition, and whoa, I just made a much bigger line than I intended to make. My name's Jim Jacobson. That's me in the upper right-hand corner of your screen. We're going through the 12th edition to the guide to the test, and we just finished last time the problem-solving section of the book. So we're picking up on page 273. I suppose the section really starts on page 272, but I'm not going to do. I don't want to make a liar out of the advertisements, but they give a sample problem in the in the explanations on data sufficiency. I'm not going to do that one, but we're going to pick up with all the real problems on page 273, starting with question number 1. So, just a few words on data sufficiency in general. So we're on page 273, question number 1. One of the key differences, of course, that this is a question format unique to the GMAT. You don't find it on the GRE. You certainly don't find it on the LSAT. You don't even have any math there. The answer choices are always the same. And so, of course, they're always A, B, C, D, E. I personally find it helpful to write out 1 to 10. As a reminder, of course, you do enough of these, you'll have the whole thing memorized. But as a reminder that answer choice A is that statement 1 is sufficient on its own. Choice B is that statement 2 is sufficient on its own, and then each of them, the other statement is not sufficient. Choice C is that they are insufficient individually, but T stands for together, that the two statements are sufficient. Choice D, I have E here, that stands for either one is sufficient on its own and you don't need to combine them. And then choice E, neither. Neither one is sufficient on its own, and in combination they remain insufficient. One other little kind of thing to remember is that basically there are typically two types of data sufficiency questions. We have value questions, and it actually mentions these specifically about a third of the way down the page on page 272 in the explanation. With value questions, you need one single value. If you get something where x equals 2 or negative 2, or negative 2 or 2, I wrote the reverse of what I said. Anyway, if you get something like this, this statement would be insufficient. You need one value. It doesn't matter which one it is, but you need one single value. The other type of data sufficiency question is the yes-no question. Is x odd? Or, is n divisible by 3? And the answer for a statement in that one to be sufficient, it needs to always be yes or always be no. Either one is sufficient. It's only that if it's sometimes yes or sometimes no, depending on what the value of the variables are or depending on what numbers you pick, that's when those statements are insufficient. So it's a kind of a different approach to problems, and it's more about it is about whether you have enough information to solve the problem and answering it in a very specific way, namely in the value or yes/no way. And of course, I'll be highlighting this as we go. So I'll clear that all that stuff out. But it's 273, question number 1. So what is the value of the absolute value of x? So one of your first steps when you get any data sufficiency problem is to figure out what you would need to know in order to answer the question. The hope is that you'll recognize that thing in some form in one of the two statements right away and be able to make some determinations initially. So, we need value of the absolute value of x. Really, to know that, basically we need to know what x is. So statement 1 says that x equals the opposite of the absolute value of x. Well, remember this is a value question. What is x? There's no numbers at all in this one. So even without thinking about it too terribly much, we need to know what x is, or actually what the absolute value of x is, and there are no numbers at all in this question. So statement 1 on its own is going to be insufficient, which means we can cross off answer choice A. We can also cross off answer choice D, because that one represented either answer choice being sufficient. So, and that's a really good habit to get into on data sufficiency questions, is crossing off answer choices that can't possibly be right, because you may run into a statement. Of course, if things are going great and you're just kicking the GMAT's butt, every statement will become immediately clear to you, but let's just pretend that for some reason something happens and a statement just you can't figure out whether it's sufficient. At least crossing off answer choices that cannot be the correct answer based on what you have been able to figure out improves your odds of getting the question right. So again, when I give you strategies like this, I'm not assuming that you're going to do poorly. I hope it doesn't undercut your confidence in that way. It's more about strategies for maximum success on the GMAT. You may never have to use this. Every statement may be crystal clear. Anyway, statement 2, we have to ignore what we just learned from statement 1. That's the big trick, is whichever statement you do first, and you don't always have to do statement 1 first. I usually will, unless one just jumps off the page as being much, much easier. But when you do the second statement, you have to put the first one that you did out of your mind. It can be tempting to go immediately for choice C, that the two statements are sufficient together, when in fact one of the two statements may be sufficient on its own. So that's why you have to kind of forget everything you just did. So we have x squared equals 4. Remember that when you have things on the GMAT like the square root of 4, that's only the positive square root. So the square root of 4, that equals 2. The square root of x, well, that would be solving for x squared equals 4, where you take the square root of both sides, though. Without using the square root symbol, you get both roots. So x equals plus 2 or minus 2. Now, the original question was, what is the absolute value of x? Even though I said we need to know what x is, I suppose I should have said we also would have accepted what is the absolute value of x. Since we know what x is, 2 or negative 2, the absolute value would be the same in both cases. The absolute value of x, it's always a positive number because it's a distance from 0 on the number line. So absolute value of x equals 2. So statement 2 alone is sufficient, and that means answer choice B is our friend for our first question. Let's move on. So 273, question 2. I'm going to keep doing this because this is just the habit I've been in over the years, doing GMAT questions. It makes my life easier, reduces confusion. I even do this on, the scrap paper on the test and everything. So, okay. What percent of a group of people are women with red hair? So the percent of people with red hair, percent of women with red hair would equal red women, and of the group, it'd be all the women and all the men. So we need these numbers in order to figure out what the percentage is of women with red hair. So statement 1. Of the women in the group, 5% have red hair. So that tells us that red women over women equals 0.05. Note, though, that we still need the number of men in the denominator of the fraction to get the percent that we're actually after for this question. There's no other information about the men in the group. I guess I have to say I cheated a little bit. I know there's men in the group because that's in statement 2. Forgive me for that one. We would have figured that out eventually, though. So statement 1 on its own is insufficient. We can cross off numbers 1 and 4, choices A and D. Statement number 2. Of the men in the group, 10% have red hair. So red men over the men equals 10%. It works the same way as statement 1. We aren't given anything about women or red-headed women, so or women with red hair. So this statement alone is clearly insufficient. We can get rid of choice B. So our only choices here are that neither is sufficient on its own or in conjunction, or that combining the two, they somehow give us what we're after. Now, because we're given these ratios relative to the individual subpopulations, and we are given no information whatsoever about their real numbers or their relationship to each other. I mean, if we had been given, you know, women equals 2 times the men and men equals 10 or something like that, in addition to the information that we had here, that would have been enough to determine this. But to figure out the percentage, we need actual numbers in this equation up here, and we have no numbers at all. So even in conjunction, the two statements are insufficient. Answer choice E, neither one. Statements 1 and 2 together are not sufficient. That's what it says over on the previous page. Okay. 273, number 3. In a certain class, one student is to be selected at random to read. What is the probability that a boy will read? So remember, probability. And of course, if you've been watching all the rest of the broadcasts in the series, you've seen me do the probability fraction about 1,000,000 times. But I kind of want to assume that no one has watched the whole thing and that they may be zooming in for a particular problem or may just be tuning in for the first time. So probability is always a fraction between 0 and 1. Inclusive, where something could be 1, where it has a 100% chance of happening, or it could be 0, where it has no chance whatsoever of happening. And that fraction is computed by determining the desired outcomes. Whether you really want them to happen or not, we call them the desired outcomes. They're the things that you're trying to figure out the chance of them happening, over the total outcomes. So it always comes out as a fraction, which you can also convert to a percent. In this particular question, we want to know what the probability is that a boy will read. So the desired outcome is a boy, and the total outcomes are all the students. That's the information we will need to determine sufficiency. So statement 1, it says 2/3 of the students in the class are boys. So the ratio of boys to students equals 2 to 3, which means that 2 out of every 3 students are boys. That actually makes our probability of selecting a boy for reading in the certain class to be 2 out of 3. So, with data sufficiency, you have to resist the urge to calculate whenever possible. But in this one, it basically fell into our lap. So I don't think we should feel too bad about this one. Statement 1 then is sufficient. Our odds are 2 and 3 of getting a boy, selecting someone at random in this class. It means we can cross off B, which says that statement 2 alone is sufficient. We can also cross off C, which says that they are insufficient on their own. Clearly they're not. And we can also cross off E. So just getting that one statement marked off as sufficient, if you're able to mark off one as sufficient, you already have a 50% chance of getting the question right. It's pretty awesome in a way. It almost makes up for the difficulty of getting a whole series of problems that you can't actually solve necessarily. Anyway, so the second one says 10 of the students in the class are girls. So so the fraction of boy over students, we could have just as easily written it out as boys over the fraction of boys plus girls. Spell girls correctly. So we get girls equals 10. We don't get any information at all about boys in statement 1, or excuse me, in statement 2, and that's really what we're actually after, is the probability of getting a boy doing the reading. So statement 2 alone, insufficient. We can cross off D, and answer choice A, statement 1 alone is sufficient, is the correct one. Okay. Number 4. In College X, the number of students enrolled in both a chemistry course and a biology course is how much less than the number of students enrolled in neither one? Okay, so this is one of those overlapping sets problems you may remember doing or seeing these Venn diagrams when you are given groups where people can be in one or more groups or in neither. So we have group A, group B, This is both, and then this is neither. And then the formula for computing whatever elements you're missing from this picture, A plus B plus neither, because they're not accounted for in that initial figure, minus both. We have to subtract that number once to make sure because otherwise we're double counting the people in that group, equals the total. So, and this question is actually asking us how much the number enrolled in both is how much less than the number enrolled in neither. So we would actually basically be figuring out this part right here, the difference between the neither and the both. So if we can get A, B, and the total from our statements, we are set. Statement 1. In College X, there are 60 students enrolled in a chemistry course. So let's just say that that's A. A equals 60. Remember, we need A, B, and the total for sufficiency. So statement 1 on its own is going to be insufficient. It's not going to be A, and it's not going to be D. Statement 2, in College X, there are 85 students enrolled in a biology course. So B equals 85. That on its own, we needed A, B, and the total to solve for this bit here. And so this is insufficient on its own. We can get rid of this one. Now we just have to see if together they are enough. Well, so these two give us A and B, but we still don't have the total. And so we won't actually be able to figure out what this quantity is here. So without that remaining bit of information, and we can't just add A and B together, that does not equal the total because it doesn't account for the neither and doesn't tell us how many are in both. So the two statements in conjunction still are insufficient, so we can't use the together one. Choice E. Neither one on its own is sufficient, and even when they work together, they still aren't enough for us. $273. What are we on? 5? We're on 5. I hereby declare we are on 5. I'm pretty sure I'm right this time, unlike last time where I skipped a question. Still sorry about that. I went back and did it, but you know, stuff happens with live broadcasts. Anyway, question number 5. A certain expressway has exits J, K, L, and M in that order. What is the road distance from exit K to exit L? So we have J, some distance, K, some distance, L, and then M. They're in that order. That's great. What's the distance from K to L? So we're after this distance here. So, I mean, really, for this one, we could figure it out if we were given ratios of the relative distances between each other, and then some numbers to kind of apply those ratios to the distances. We also could just be given flat out distances, but it really would need to be very specifically like J to K, and then J to M, and then L to M. We need enough to eliminate exactly which part is K to L. Let's see what the statements give us. So the road distance from exit J to exit L is 21 kilometers. I say kilometers. I make a big deal out of this just because I realize that there's people all over the world paying attention to this broadcast, all 12 of you or whatever, and some of you may have grown up saying kilometers. So and probably you're right, but in this country we say kilometers, so if I say that, don't freak out. We're talking about the same thing. Anyway, the road distance from J to L is 21 kilometers. So what this means here is, so we have J to L equals 21. And we need K to L. The issue here, though, is we don't know how that's divided. So relatively speaking, it could be JK, huge distance, L equals 21. Or it could be J, oops, that's supposed to be an L. Could be J and then KL. equals 21, i.e. there could be just 1 there and 20 there, or there could be 20 here and 1 there. And we can't tell because we're given the distance between 2 points, and we don't know where the midpoint is. It's not the midpoint. We don't know where an intermediate point is when we're given just that longer distance. So statement 1 on its own, insufficient. It's not A, and it's not D. Statement number 2, the road distance from exit K to exit M is 26 kilometers. So K to M equals 26, and it's exactly the same problem. So we have, it could be KL long way to M equals 26, or K and then a long way to LM equals 26. Again, where this could be 1 and this is 25, or this could be 25 and then the 1 could be here. So we have a wide variety of distances that we could have between K and L in both cases. And again, so this one is insufficient. We can cross off choice B. So either these are together sufficient or it's still not enough. So even with these two bits of information combined, we can still shift around all of these things. So it could be, we could combine any one of these in statement 1 with any one of these in statement 2. There's nothing that allows us to eliminate these relative distances. So, so it could be J, K, long distance, L, and then even long distance M, or it could be J, long distance, K, L, M, it could be anything. So without something to further narrow it down and give us just K to L, these two statements together are still insufficient. We cross off answer choice C, and it is answer choice E for neither one. E for neither, or neither. You can say it either way. Okay, on to number 6. 273, number 6. 1, 2, together, either, neither. If n is an integer, is n plus 1 odd? Is n plus 1 odd? So really here, if n is an integer, is n plus 1 odd? What we're really wondering then is n even or odd? Because whichever one it is, n plus 1 will be the other one. So really we just need to know something in relation to n in sequence, something before or after it that tells us n's relative evenness or oddness. So statement 1 tells us that n plus 2 is even. So let's put up a chart here. So if we have, I'm just going to peek ahead, I can see that statement 2 tells us that n minus 1 is odd. So let's just make our chart n minus 1, n plus 1, and n plus 2. It's not a proper chart without lines. So statement 1 here tells us that n plus 2 is even, which makes n plus 1 odd. It makes n even and n minus 1 odd. The question asks us, is n plus 1 odd? And so statement 1 tells us, yes it is. It is in fact odd. So this one is sufficient on its own before we even got to statement 2. That doesn't mean we stop. We still have to determine the relative sufficiency of statement 2, but we can cross off answer choice B, we can cross off answer choice C, as well as answer choice E. Those are all the ones which have at least one, well, C and E have at least have both of them as insufficient, and choice B has statement 1 as insufficient, which we already found out is not the case. So our odds are down to 1 in 2 of getting it right. Statement number 2 tells us n minus 1 is odd. We can use this same chart. N minus 1 is odd, so n must be even, so n plus 1 must be odd, and n plus 2 must be even. And so that too, it gives us the exact same information. It's enough to tell us yes, and it's always yes. Remember with yes/no questions, this is one of these yes/no guys. It has to be always yes or always no for sufficiency. Either one is sufficient. Even if it's always no, it's sufficient to answer the question. In this case, n+1 is definitely odd, no questions asked. Both statements are sufficient. Answer choice D is our right answer. (273), number 7. For which type of investment, J or K, is the annual rate of return greater? So we have J and we have K. Quite frankly, there isn't a lot of prefiguring that we can do on this one. You won't always be able to do any kind of analysis in advance. We're just going to need to know what their relative rates of return are, either in actual numbers or in some kind of ratio where we're given them in comparison, or in comparison to a third thing. Those would be the ways that we would have sufficiency that I could think of off the top of my head. Be prepared, actually, incidentally, to be surprised by what the questions give you. You may have in your head, well, if I get this or this, then I'll have sufficiency. And then the problem will give you something else completely different that you didn't anticipate. So while it is useful to do a little pre-thinking about what types of statements would be sufficient, do be open to the idea that something contrary to your expectations could show up. The GMAT test makers are clever people and like to surprise you. It makes sure that a statistically significant number of people will get the question wrong. Okay, so statement 1, type J returns $115 per $1,000 invested for any 1-year period, and type K returns $300 per $2,500 invested for any 1-year period. For those having trouble kind of seeing that in math terms, turning the words into math, that basically says that J is 115 over 1,000 and K is 300 over 2,500. We don't have to do any more math, okay? We don't even need to know which one is greater. We just need to know whether we could know which one is greater. Each of these is reducible to a fraction or a percent in the same terms. It's reducible to a decimal. And whichever one ends up being greater, or if they're equal, we would have our answer. And there would only be one answer. So statement 1 on its own is sufficient without even doing any more math. So we can cross off B, we can cross off C, and we can cross off E. If you're worried about it, how you would actually solve it, note that they have similar denominators. So we would just multiply J here times 2.5 over 2.5. Come on, there. So that would give us a denominator equal to 2,500, and whatever the numerator is would equal, something else. It turns out it equals 287.5 over 2,500. So K is the better investment. But unless it's your last question on the GMAT and you have tons of time, or you are just really, really not sure of yourself, you really shouldn't be calculating stuff like this on the GMAT. Again, unless you have time or it's fun or fast for you and it's not going to interfere. Most of the time, though, don't do it. Okay. Statement 2, then. The annual rate of return for an investment of type K is 12%. K equals 0.12. That's great, but remember we're doing this on its own, statement 2 on its own. Would this have been enough to figure out whether J or K is better? No, because there is no J. So statement 2 on its own is insufficient. That allows us to cross off answer choice D. Statement 1 on its own, answer choice A, was enough for us to answer the question. On to the second column on page 273. I just provide that for reference. All of you are presumably following along in your book. So this is question number 8. I don't even know if this is watchable if you don't have your book in front of you. I mean, yes, someone can read you a problem, but without the problem to refer to, I think this would be difficult. So I'm not saying that to try to get you to buy copies of the official guide. I don't get, money for that or something, but really this broadcast is a lot easier with a book in front of you. Okay, so question number 8. A citrus fruit grower receives $15 for each crate of oranges shipped and $18 for each crate of grapefruit shipped. How many crates of oranges did the grower ship last week? So we have one of these things. This is two equations, it's two variables, and whenever you have two variables, you need two equations to solve for both variables. If this were a problem-solving question, we would probably get something, so let's just say R equals oranges. I hate using O for variables because it's a high-risk thing because it looks like a 0. And we'll use G equals grapefruit. So were this problem solving, we would probably get two equations like the oranges. Whoa, I even used O there, even though okay, forget that. Oranges plus the grapefruit equals 273, and then we would get a rate 1. It would equal the number of crates shipped, and then we would get another equation, which would be, we would create the other equation, 15R plus 18G equals whatever their dollars were. So something like that, it would likely give us sufficiency if we got those two equations or some other types of equations. Anyway, on to the statements. Statement 1 tells us, last week the number of crates of oranges that the grower shipped was 20 more than twice the number of crates of grapefruit shipped. So it's not quite this one here that we typically got, but that basically says the number of orange crates shipped was 20 more than twice the grapefruit. So 2G plus 20. It was 20, right? Yeah, it's 20. So we have two variables with one equation. And since we are actually being asked for the value of one of the variables rather than a relationship between the two variables, the statement is insufficient. So it's not A and it's not E. What does statement 2 bring to us? It tells us last week the grower received a total of 38,700 from the crates of oranges and grapefruit shipped. So $15 times the number of orange crates plus $18 times the number of grapefruit crates equaled 38,700, which is great for crates. And again, we have to put statement 1 out of our mind. I'm not going to cross it off because we still have to compute them together. But on its own, this is still one equation with two variables, and that is not sufficient on the GMAT or in algebra in general. So statement 2 is not sufficient on its own. We only have looking at the two in conjunction. In conjunction, of course, because of the preview, and maybe this seemed like I was kind of giving it away by giving this information in advance, but you really can do this type of thinking. You probably would not write down these equations, but you would remember from your previous practice and from other problem-solving questions you may have already done on the GMAT at that point that this is the typical format for these types of questions, and so you'd say, hey, I'm probably going to need something like that. Then when it shows up in the answer choices, here's one equation with the numbers of crates or their relative values, and then we actually bring it back into the dollar amount. That's exactly the type of thing that you were expecting, and so those two statements together are sufficient. Two equations, two variables. We would probably, there's a couple ways you could do this one. You could either combine them by multiplying each of these, all of the things in statement 1 by 15, and then subtract the two equations together, or substitute this value here in for R, and then you're down to one equation and one variable. Either way, you'd get the right answer, and either way, the right answer is C. The two statements together are sufficient, even though they are individually insufficient. $273, number 9. If Pat saved $600 of his earnings last month, how much did Pat earn last month? So we have the savings equals 600. We would need like what fractions of his earnings his savings were. So $600 is X% of his earnings. That would be the sort of thing that we would want to see. Do we get it? Statement 1 says, Pat spent 1/2 of his earnings last month for living expenses and saved 1/3 of the remainder. So his total earnings, let's just imagine it's a pie. He spent half on his living expenses, and then he saved 1/3 of the remainder. He saved that much. And so mathematically, I mean, you could kind of eyeball this, I guess, but really he did, so that if this is 1/2, then this is also 1/2. His savings equaled 1/3 of 1/2 of his earnings. And we know that that's 600, so 600 equaled 1/6 of his earnings. We don't even have to figure out what his earnings were. We just know that we could figure it out. We have one equation and one variable, and it's enough. So statement 1 is sufficient on its own. We can cross off B, and we can cross off C and E, because those have statement 1 being insufficient on its own. It's either A or D in a cage match to the death. Let's take a look at statement 2 to figure out what it has to contribute to this question. Of his earnings last month, Pat paid twice as much in taxes as he saved. Well, so we know that taxes equals 1,200. His taxes were twice as much as he saved, and that's of his earnings. But we aren't given anything about his earnings or his earnings relative to his taxes even. If we'd been given that, we would have had sufficiency. We don't have a way to get back to E. We need to get to E, please. So statement 2 on its own does not give us anything that gets us back to something like we had in statement 1. It's not enough, insufficient. That allows us to get rid of D. Answer choice A is our answer. Okay, 273, number 10. Water is live broadcast for you. Water is pumped into a partially filled tank at a constant rate through an inlet pipe. At the same time, water is pumped out of the tank at a constant rate through an outlet pipe. At what rate in gallons per minute is the amount of water in the tank increasing? So we have water coming in and water going out, and there's a difference between the two. It shouldn't be the same number. And it sounds like the in is going to be greater than the out. And in order to figure out how much greater the in is than the out, we need both of these numbers, both of these rates. So let's look. Statement 1, the amount of water initially in the tank is 200 gallons. Well, this doesn't give us either of the rates that we were after. It doesn't give us the incoming rate. No. It doesn't give us the outgoing rate. No. It just tells us that there were 200 in the tank, which actually doesn't really even matter. It could have started at 0. It could have started at 1,000. We're after the rate that it is increasing in its volume. So the actual initial volume is totally irrelevant. The statement is insufficient, so it's not A and it's not D. Statement 2, water is pumped into the tank at a rate of 10 gallons per minute and out of the tank at a rate of 10 gallons every 2.5 minutes. So in equals 10 per 1 minute, out equals 10 per 2.5 minutes. That gives us the in rate and the out rate, and that's enough to tell us it's sufficient. But in order to make it look more like if we were really solving it, we would say this is 10, well, we would multiply this guy times 2.5 over 2.5, so we would get 25 over 2.5, and then the out would stay 10 over 2.5. And from there we could figure out how much faster in gallons per minute the water's coming in, then it's going out. So statement 2 is sufficient on its own. That allows us to circle B and cross off C and E, which required it to be insufficient. Okay. 273, number 11. Is x a negative number? Okay, so this is one of those ones where you can't do a whole lot of figuring. We need x. What is x? Also note that it's a yes-no question, so the answer needs to be always yes or always no for sufficiency. Let's see what the statements give us. Statement 1, 9x is greater than 10x. If you can't just sort of logic your way through that one, we can just subtract a 9x from both sides. And so, then we get, 0 is greater than 10, or excuse me, 0 is greater than x, which means x is less than 0. So x is definitely a negative number. So it's sufficient, and yes, the answer is yes. You could have just said the only way that 9x could be greater than 10x, if x is positive, there's no way that this could be true. So x must be negative because 10x would be a more negative number. But you can also just rely on algebra. Subtract 9x from both sides, you get 0 is greater than x. Statement 2, x plus 3 is positive. So, for this one, we can kind of pick numbers. I mean, of course, if x equals 3, then then x plus 3 is positive, and x is positive. If x is -1, for example, x plus 3 is still positive because it's 2, but then x is negative. So because choice statement 2 is sometimes yes, sometimes no, it is sufficient on its own. So, sorry, with the first one we could have crossed off B and C and E. With the second one being insufficient, we can cross off D, leaving us only answer choice A as sufficient. On to number 12. 273, number 12. 1, 2, 10. If I and j are integers, is I plus j an even integer? Is I plus j an even integer? Good question. So basically, we need to know something about the evenness and oddness of I and j. That's the prediction I have about what we would need from our statements. Because remember, odd plus odd is even plus even is even, but even plus odd is odd. Okay, so statement 1 tells us that I is less than 10. That gives us a massive range. I mean, we've established that I is an integer, so but that's still an infinite number of numbers less than 10. Basically half of which are even and half of which are odd, and we don't have j in this equation at all. So no j, which means that statement 1 is insufficient on its own. We can cross off A as well as D. Statement 2 tells us that I equals j. So this actually is interesting, which means then that we can substitute I and j for each other. So I plus j is the same thing as I plus I. So that's this equation plus this substitution, I plus I equals 2I. So I plus j equals 2I. And an important rule of the GMAT is that an even integer, even number, really, times any integer, even or odd, gives you an even number. Even number times anything gives you even. So I plus j is equal to 2i. 2 is an even number. So this 2i thing, that absolutely has to be even 100% of the time because of this rule. So statement 2 is sufficient. We can cross off C and E, and with confidence, I put a square around B on the real GMAT. You would click on B and then confirm your answer. And so we are on to our last one on page 273, number 13. The charge for a telephone call between city R and city S is 42 cents for each of the first 3 minutes and 18 cents for each additional minute. A certain call between these two cities lasted for X minutes, where X is an integer. How many minutes long was the call? So before we get too far into it, we can just pretty much whip off a quick equation describing the information that we've been given in the original passage. So a call is 42 cents for the first 3 minutes, plus 18 cents per minute for the minutes over 3. Good to know. Which then comes out to $1.26 plus 18 cents for the minutes over 3. And yes, we could have written minutes over 3 as just x as a variable, but it's useful sometimes just to kind of keep it clear, especially when you're teaching. So let's take a look at the statements. Statement 1 tells us the charge for the first 3 minutes of the call was 36 cents less than the charge for the remainder of the call. So that gives us the relative quantities. The first 3 minutes of the call was 36 cents less than the remainder of the call, which means that 126 equals 18 cents times the minutes greater than 3 variable plus 36 cents. And we could figure it out from there. We would subtract 36 cents from both sides, divide by 18 cents, and that would give us the number of minutes. And I mean, we're not going to do the math, but we could. We know we could, so we can confidently cross off answer choices B, C, and E, because statement 1 is sufficient. Statement 2. The total charge for the call was $2.88. So that we can reuse our equation again. $1.26 plus, of course now I'm wishing I had just assigned this as a variable at the beginning, but you know, whatever. $1.26 plus 18 cents times the minutes greater than 3 equals $2.88. So again, we have a single equation with one variable. We would subtract 126 from both sides and then divide by the 18 cents for the remainder, and that would give us the minutes that are over 3, and then we would know that the final number in any case would be, you know, this guy plus 3. Anyway, sufficient for sure, which gives us answer choice D. This concludes page 273. I think we have time for a couple more at this rate. It's important that I not go over time. Some of you have busy schedules. Some of you have stayed up late or gotten up early to watch this broadcast. So it's the least I could do to be timely. Number 14. 1, 2. Okay. If car X followed car Y across a certain bridge that is 1/2 mile long, how many seconds did it take car X to travel across the bridge? Okay, so it's a 1/2 mile bridge. Not everything that I'm writing on, I guess I should mention, a lot of the things that I write on the screen are actually really helpful and really do mimic certainly what I would do solving these problems on the real GMAT, but are also things that you could do. There are some things that I write out that probably you would not, that it's more for explanation purposes and showing visually as well as orally, audially, what things I consider important from the problem. So we have car X and car y. And we need to know how many seconds did it take car x to travel across the bridge. To solve for this one, we basically need to know how fast car x was going. Okay, because if we know car x is miles per hour, with a half-mile bridge, we can figure out how long it took car x to cross the bridge. The fact that there's car y involved tells us already that probably what we're going to get, if anything, is car x's speed in relation to car y's. Because that's how these problems work. If they just gave us car x's speed in one of the statements, well, it wouldn't be much of a problem. Not too many people would get it wrong. So, on to the statements. Statement number 1, car x drove onto the bridge exactly 3 seconds after car y drove onto the bridge and drove off the bridge exactly 2 seconds after car y drove off the bridge. Did I read that right? I think I did. I'm not going to try it again. Anyway, the point is that car x started 3 seconds behind car y and ended 2 seconds behind car y. So, basically, it gives us that that car x is going 1 second faster than car y. So I guess this would be car x minus car y equals 1. Well, we'll just call it 1 second. That's all we really know about their speeds. But that doesn't tell us. It tells us their relative speeds, but we don't actually know how fast they're going. Car y, so statement, so insufficient, get rid of statement A, and statement D, or answer choice D. So statement 2, car y traveled across the bridge at a constant speed of 30 miles per hour. So here, we have, so car y traveled at a speed of 30 miles per hour. 30 miles per hour over a 1/2 mile bridge. That's the same thing as, it would be the same thing as 60 miles per hour over a 1 mile bridge, which is the same thing as car y is going 60 miles per hour. Yeah, anyway. Okay, sorry, got a little lost in thought there. So we know that this is car y's speed, 60 miles per hour, but we don't know how fast car x is going. So we don't have that statement is also insufficient, so we can cross off B. We are left with C and E. These two together, though, car y at 60 miles per hour would have gone over the bridge in 60 seconds, right? Let's see. Yeah, 60 seconds. So car x would be 1 second faster than that. It would be 59 seconds. So the two statements together do actually give us enough information to determine how long it took car x to cross the bridge. Those two statements are sufficient. Answer choice C. Together, they are sufficient. And let's look at that next one. Oh yes, totally have time for the next one. So 274, number 15. If n plus k equals m, what is the value of k? N plus k equals m. 3 variables, so and we need the value of k. So basically, we need numbers for n and m to solve for this one, because only a single value for k will be sufficient. So statement 1, n equals 10. And sadly, we are missing m here. If we had m, we could perhaps solve it, but we don't. So it's insufficient. We can cross off statement 1. We can also cross off statement, or answer choice 1 and answer choice 4. Choices A and E, or D, sorry. Ooh. Okay. Statement number 2, m plus 10 equals n. Well, we can actually put this in the format, you know, blah, blah, blah equals m. So let's do that. N equals m. No, yeah, let's start off with that. N equals m plus 10. We subtract 10 from both sides. N minus 10 equals m. Well, n minus 10 equals m, in terms of how that maps onto n plus k equals m, clearly k equals negative 10. So in this case, we do have enough to answer the question for what the value of k is. That's what the question is, right? Yes, value of k. So statement number 2 is sufficient. Answer choice B. We can cross off C and E because statement 2 was sufficient on its own. And I think we have time to get through number 16 quickly. 274, question number 16. I probably shouldn't have rushed it. I'm sorry about that. But number 16, flat out, is x an integer? We're asking about x being an integer. This is a yes-no question, so always yes or always no is the only thing that's sufficient. If we get sometimes yes, sometimes no, it will not be sufficient. Not a whole lot of prefiguring we can do. We just need to take a look at the answer choices, or the statements in this particular case. We get statement 1, x over 2 is an integer. Which means, basically, in order for x over 2 to be an integer, that means that x is an even number. Because only even numbers can be divided by 2 and still give you an integer. If x is an even number, then x is definitely an integer. So this is sufficient to tell us yes, that x is an integer. So we can cross off B as well as C and E as our answer choices. Let's take a look at statement 2. 2x equals an integer. So this is a trickier case where picking some numbers can help illustrate our issue. If x equals 1, 2x also is an integer. So x was an integer, so this is yes. If x equals 1/2, 2x equals 1. So 2x equaled an integer, but x itself was not an integer. So no. So statement number 2 is one of these sometimes yes, sometimes no, depending on what type of value you pick for x. That's not sufficient on data sufficiency questions. It's a big I for insufficient, which means we can cross off answer choice D and confidently select answer choice A. Statement 1 alone is the one that's enough to answer the question. So I think that's a good place to stop. We got done with just a minute or so to spare. Once again, my name's Jim Jacobson. I've been your teacher today. Next time we will pick up right where we left off on page 274. We're going to start with question number 17 on page 274 in the data sufficiency section. Thanks for joining, and stick with us. We're going to get you cover to cover through the 12th edition of the guide. See you next time.